Testing, testing. Well, the sun's coming up. I wish I had done more yesterday, but it's early Sunday morning now, and I'm jumping back into basically taking a look at online scripts that are written in, as you can see here, in Rhino script syntax. Fairly simple, making a list A. I've imported math. Actually, they've imported math, and they've used it here as math.sign. But let's just walk through it. A is a blank list, and for I in range 100, you're going to draw out points along this side of this shape, and it's actually going to dance a bit in the z direction because of sign and a multiplier on that by 10%. If you want to think of it as a percent, what's nice is this is just set by a multiplier of 1, but if you put a slider on here and consider maybe putting in a variable there and having it input, keep in mind this x and y is not this x and y, so that's a little confusing. So what I should probably do is just take off those things and show you that the script works fine without those x and y's. That could be kind of tricky if you're not attentive to that, but basically it's a little dance of this going from range I1, but while it goes from 0 to 100 and dances in that direction, it's also got a nested loop of j in the y direction, which is doing its own little dance, which is kind of nice. It actually, as it goes in there, that'll be the dance, I'm sorry, in the y direction, which is a multiplier. And if you've moved outside of that range of 0 to 50, then you're going to be doing the else. Once it gets out of that loop, it's going to dance into the other loop and do its little point projection on its z-axis in this way, which is actually not using any trigonometry. It's using a pretty hard-coded 20 minus j iteration, which will be 0 to 50, modular 20, which is going to make it above and below. I think if you go 50 modular 20, you're going to get 10 remainder times 0.2. So you can get into the maths and get lost in here. And needless to say, maybe you don't want to, because it does start to get a little tricky on the mind. And you can watch how it's generated slowly. But that is really just building this bottom section. So what I did was I went in and I said, okay, well, we want to translate this to rhino.geometry at RG and import the maths. You don't really have to import the maths because it's up here. But if I removed this with triple quotes, you'd see that we're back into for I in range. And I want to show you the power range does not have to just be 0 to a number. You can do the start, the stop, and the step between it, and you end up with a totally different mesh. So at this point, I am going to leave this. I'm going to go back into shaded. I'm going to take that object and get rid of it and show you what's actually happening if I was to focus on the surfaces that are being corrected. Now, these don't have to be surfaces. This is what gets very interesting. These surfaces could be brought in if you didn't want, because all I've done is taken the top and bottom surface after the equation, making a top and bottom piece, and I've taken the sides and looked at the edges and lofted between them. So I got this very strange kind of funny pattern that's lofting up from this shape and this shape. Now keep in mind, that's what I'm doing from surface, the surface end curves. But if you didn't want actually the surfaces to be seen, these two, you could preview those off. And now you're just seeing, well, I've selected them, but basically you see the loft without those tops and bottoms. And you could put on, and this is where I find Grasshopper very interesting, you put on Delaunay mesh and grab your A, and you could grab your B just by pulling them in. And I don't mean to do this, but I find it exciting. You can see where that math really makes for a much different point count on a mesh. So it's not an estimated surface. So you may want to go in and have a comparison of that mesh, which is fabricatable, to this mesh, which is fabricatable. So even though you're dealing in NURBS curves and NURBS surfaces, with the other thing, you see it doesn't line up exactly to that. So if I grab my loft and I grab this surface and this surface, you start to see the problem of working with NURBS lofts along with meshes. And now you've got this margin of error, which you can use certain plugins or you can use your own brain to get in there and find out, okay, how would I have to fine tune those areas that pop up from the corners and leave these little spaces and make it fabricatable? How would I fix those? And you could do that in Rhino, but at some point you want to get your shape and your script over to some type of fabrication, get close to what you want. But I really find these shapes very nicely, and this mesh coming from the exact same loop at least the algorithm of playing with it. And because I'm going in here and I'm stepping 8 as opposed to stepping uh, uh, just 1, you can see the difference. Sorry, stepping 6, you can see, and stepping 8 in the X and Y direction. You're going to have this totally different delineate mesh that's created as opposed to the one that was on the bottom one, which is the standard one that they gave you, which is actually kind of nice. But I find when meshes start to get smooth, people start to want the NURB surface, and when meshes start to get a little more quad and tri, people are like, hey, I can actually see that and imagine that in the world. And yeah, I'm throwing that out there, and I didn't mean to ramble about this. Basically, I just wanted to show you how Rhino script syntax can be translated by just switching the, still it's at the basic idea of add point having to be converted to RG at 0.3D, exact same algorithm written, and I will move on to a Wickerson Studio version of this. Even though this is kind of a Wickerson Studio version of this, I will remove the Rhino script syntax, I'll deal in this, and I'll try and create some interesting geometries. And yes, I'm going to start playing with meshes and with NURB surfaces, surface for points, and keeping with that. I think it's pretty interesting to play around with this and end up with something as strange as this with a surface underneath, kind of this aquarium type structure. And it's really just the maths. Like if I push and pull this in the X and Y direction, I went from 12 to 82 and I went from 12 to 38. The reason I chose those numbers was because 12 to 82 is 12 away from 0 and 12 away from 100. And the reason I went 12 to 38 is because 12 is 12 away from 0 and 12 away from 50. So I'm playing off of these numbers. So you may want to correlate these and start writing some formulas in here so that thing will balance and maybe not just scale, but actually deform and do some weird things. So like I said, we're not making things in the Rhino window. We're not just making them in Grasshopper window. We're not just making them in Python window. We're actually going deeper and asking ourselves, what really is in these maths? And I think that's what the main focus of the Wickerson Studio tutorials have really been on. It's kind of my, I don't know what the word is, reconciling with mathematics in my life and trying to bring it back into my scripts and my sculpture. I spent a good portion of my life feeling that was the direction I needed to go, and I left that decades ago, and maybe I've used it practically and applied, but now it's time to use it much more theoretically and exercise-wise. Anyway, thanks for watching. I'll keep going with these and keep making interesting geometries and hopefully inspire others to just get lost in it, have fun. No matter where your eye is pointed, you may be a very good Revit person. You can find ways of exporting and importing using plugins, which I'm not going to get to in this series, but you can find ways of taking Grasshopper directly through, actually objects baked from Grasshopper into Rhino, and importing that into data sheets that actually feed into Revit. And I think that's where all the applications come. You've got to find your particular interest and your particular purpose. And right now I'm being very playful, and research and development go back and forth, back and forth, back and forth. You're either researching, and then you go on to develop an idea. And wouldn't it be nice to be the mathematician, the one that there was nothing to find and nothing more to study, and anything you thought is hitting on new territories and new grounds. And I think that's where the artist mind is a lot of the time. I think it's correlated. So thanks very much for watching.